Imagine standing at the edge of a human history. A single moment, just one, was enough to split the world into two eras, before the bomb and after it. A moment when the power of the sun itself was unleashed on Earth. A moment when humanity discovered that it could destroy itself with a single decision. Was this discovery the peak of human genius or the beginning of its downfall? As the philosopher Martin Heidegger once warned, the most dangerous thing about technology is that it convinces us we control it, while in truth, it begins to control us. This is not just a scientific story, it's a story about fear, ambition, power, and the fragile destiny of humanity. The birth of atomic science. The atom was not what we thought. For centuries, philosophers believed the atom was the smallest, indivisible unit of matter. But in 1897, British physicist J.J. Thomson shattered that belief by discovering the electron. Suddenly, the atom was no longer a solid sphere. It was a universe. Ernest Rutherford, the father of the nuclear age. In 1911, Rutherford performed his famous gold foil experiment. He discovered that the atom is mostly empty space, with a tiny, dense nucleus at its center. This nucleus would later become the heart of the nuclear bomb. Niels Bohr, the quantum architect. Bohr introduced a revolutionary model of the atom, showing electrons orbiting the nucleus in quantized levels. His work laid the foundation for quantum mechanics, without which nuclear physics would not exist. James Chadwick, the discovery of the neutron. In 1932, Chadwick discovered the neutron, the particle that would make nuclear fission possible. The neutron was the perfect weapon. First, it carried no electric charge. Second, it could penetrate the nucleus. Third, it could split atoms apart. The discovery of nuclear fission, a turning point. In 1938, three scientists made a discovery that changed the world forever. Lise Meitner, Otto Hahn, and Fritz Strassmann. They found that bombarding uranium with neutrons caused it to split, releasing enormous energy. Meitner provided the mathematical explanation, proving that Einstein's equation E equals mc squared was not just theory, it was reality. Albert Einstein, the equation that opened Pandora's box. Einstein never built the bomb, but his equation revealed the terrifying truth. A tiny amount of matter could release unimaginable energy. This idea would soon reshape the world. The global race for the bomb. The nuclear arms race begins. First, fear, the engine of the race. The discovery of nuclear fission in 1938 spread fear across Europe. Hitler was rising. Germany had brilliant physicists. And the world knew if the Nazis built the bomb first, civilization might not survive. Fear became the fuel of the nuclear race. Einstein's warning letter in 1939. Although Einstein was a pacifist, he signed a letter to President Roosevelt, warning that Germany might be developing a nuclear weapon. This letter triggered the creation of the most secret scientific project in history, the Manhattan Project, the birthplace of the bomb. The United States launched a massive scientific and military effort involving Robert Oppenheimer from USA, scientific director; Enrico Fermi, Italy, USA, built the first nuclear reactor; Leo Szilard, Hungary, USA, conceived the chain reaction idea; Niels Bohr, Denmark, provided theoretical insights; Richard Feynman, USA, young genius of quantum physics; Hans Bethe, Germany, USA, head of theoretical division; More than 130,000 people worked on the project across 30 secret sites. Germany fails, but the race continues. By 1944, it became clear that Germany's nuclear program was disorganized and far behind. But the United States continued anyway, because the world had changed. Nuclear weapons were no longer a possibility. They were inevitable. The Soviet Union joins the race. After World War II, the Soviet Union, led by physicist Igor Kurchatov, began its own nuclear program. Soviet spies infiltrated the Manhattan Project and passed key information to Moscow. The Cold War begins. The superpowers now possessed the most destructive force ever created. The world entered a new era, an era defined by suspicion, fear, and the constant possibility of annihilation. Nuclear nations, and when they got the bomb. Who has nuclear weapons today? The first nuclear powers. First, the United States in 1945. Then the Soviet Union, today Russia, in 1949. After that, United Kingdom in 1952. Then France in 1960. After that, China in 1964. These five nations are recognized as official nuclear states under the Non-Proliferation Treaty (NPT). The other nuclear states, India in 1974, then Pakistan in 1998, after that North Korea in 2006. The ambiguous case of Israel. Israel is widely believed to possess nuclear weapons, though it has never officially confirmed or denied it. Estimates suggest it developed them in the late 1960s. Former nuclear states. South Africa built nuclear weapons in the 1980s, then dismantled them voluntarily in 1991. NATO nuclear sharing. Countries like Germany, Italy, Belgium, the Netherlands, and Turkey host US nuclear weapons under NATO agreements. Nuclear deterrence and global balance. How nuclear weapons shape world power. The logic of deterrence. Nuclear weapons are not meant to be used. Their power lies in the threat of their use. This is called deterrence. Mutually assured destruction, MAD. During the Cold War, the US and the Soviet Union realized if one launches a nuclear attack, the other will retaliate. Both sides would be destroyed. This paradox prevented war. The nuclear triad. Nuclear powers maintain three delivery systems. Land-based missiles, submarine-launched missiles, and strategic bombers. This ensures no country can eliminate another's nuclear arsenal in a first strike. Modern nuclear strategy. Today, nuclear weapons are used to prevent invasions, influence diplomacy, maintain regional dominance, and deter rival states. The philosophy of nuclear power. As philosopher Bertrand Russell said, humanity must choose cooperation or extinction. How nuclear bombs work. The science behind the explosion. The heart of the bomb. Nuclear fission. Nuclear fission occurs when the nucleus of a heavy atom, usually uranium-235 or plutonium-239, is struck by a neutron. The nucleus splits into two smaller atoms, releasing a massive amount of energy, more neutrons, and radiation. This creates a chain reaction. The chain reaction. If each fission event releases more neutrons that cause more fission, the reaction grows exponentially. This is the key. A bomb is simply a chain reaction that grows too fast to control. Critical mass. A nuclear bomb requires a minimum amount of fissile material called critical mass. Below this mass, neutrons escape. Above it, the chain reaction becomes unstoppable. Two main bomb designs. There are two classic designs. First, gun-type design, like the bomb in Hiroshima. Two subcritical pieces of uranium are fired into each other. When they combine, they exceed critical mass. Explosion occurs. Simple, but only works with uranium-235. The second design, the implosion design, like the bomb in Nagasaki. A sphere of plutonium is surrounded by conventional explosives. These explosives compress the plutonium inward. Density increases, critical mass achieved, then the explosion. This design is more efficient and used in most modern weapons. The thermonuclear bomb or the hydrogen bomb. A hydrogen bomb uses fusion, not just fission. Fusion is a process that powers the sun. It fuses hydrogen isotopes into helium, releasing energy far greater than fission. A hydrogen bomb has two stages. First, fission bomb trigger. Second, fusion fuel, deuterium plus tritium. The result, a blast 1000 times stronger than Hiroshima. Example, energy released. When 1 kilogram of uranium undergoes fission, the energy released equals 20,000 tons of TNT, enough to power a city for days or destroy it in seconds. Why the explosion is so powerful? The energy comes from the conversion of mass into energy. As Einstein predicted, E equals mc squared. Even a tiny amount of mass becomes an enormous amount of energy. The future of nuclear weapons. What comes next? First, miniaturization. Modern nuclear weapons are becoming smaller, lighter, and more precise. A warhead today can fit on a missile the size of a car. Second, hypersonic delivery systems. Nuclear missiles now travel at Mach 10 or faster. They are nearly impossible to intercept. Third, AI and autonomous systems. Future nuclear command systems may involve artificial intelligence. This raises terrifying questions. Who decides, a human or a machine? Fourth, space-based nuclear platforms. Some nations are exploring nuclear weapons in orbit. A single detonation in space could disable satellites and global communications. Fifth, the risk of proliferation. More nations want nuclear weapons. The more countries that have them, the higher the chance of miscalculation. Sixth, the hope, disarmament. Some treaties aim to reduce nuclear arsenals, but progress is slow and trust is fragile. What if a global nuclear war happens? The unthinkable scenario. The first 30 minutes. Major cities vanish instantly. Hundreds of millions die. Firestorms consume everything. Hospitals collapse. Governments fall. Then nuclear fallout. Radioactive dust spreads across continents. Water becomes poison. Food becomes scarce. After that, nuclear winter. Smoke blocks sunlight. Temperatures drop by 10 to 20 degrees Celsius. Crops fail globally. Billions face starvation. Then the collapse of civilization. Electricity fails, trade stops, nations fall into chaos. Humanity enters a new dark age. Extinction. Some scientists believe a human might survive. Others believe extinction is possible. The truth is simple. A global nuclear war is a war no one wins. A final reflection. Humanity created a weapon capable of ending itself, but it also created art, science, music, and love. The same mind that splits the atom can also heal the world. As Albert Einstein warned, I don't know with what weapons World War III will be fought, but World War IV will be fought with stones and sticks. The future is not written yet, it's a choice. Thank you for watching. See you next time.